Hello, everybody, and welcome to week 4. Seems to be the whole semester is going by pretty quick. Just think it. At the end of this week, we are a quarter of the way through the semester. So we'll go ahead and get started. This week, we're talking about the water supplies for fire protection. And really, I don't want to say this is more trivia because it is important to understand, but this really isn't something that we're going to spend a whole lot of time on outside of maybe a design phase or maybe as we look at a system trying to improve things. But for the most part, once it's set, it's set. And there's professionals that do this all the time. Your fire protection specialists, your sprinkler groups, they know this stuff inside and out. So I want to go through a lot of this stuff, some of the different options that are out there, things we need to think about. So when we look at this, and I will tell you this entire presentation basically came out of the firefighter program. I took some of the stuff out of it to really focus it down on us to make it as relevant as possible. So you look at the water supplies that we use, basically there's two different types. There's the public system and the private system, and they're just that. Public would be internal to an individual plant, an individual's company, etc. Then there's the private. That's what we normally see within our area. It's like, oh, we put hydrants in, etc. And where we get the water from, it really depends on where we're living. If you're living in Wisconsin, you have natural fresh water. It comes out of a lake, comes out of a river, it comes out of something. If you're out on the East Coast, West Coast, Southeast, whatever, it comes out of the ocean. And that's fine. It doesn't really matter if you're putting out a fire with fresh water or salt water. It really doesn't matter. There's some issues that go with it as far as the salt water can corrode some of the components faster, but it really doesn't make that much of a difference. In fact, when I was in the Navy, our fire protection system, we just pulled water right out of the ocean. It went through our loop and went right back to the ocean, and it worked really, really well. So how much you need, it really depends on where you're at. And your Department of Public Works has all of this information. It talks about how much you've had, what you're consuming, and it has to be able to do your system. A lot of these systems are I guess you could say single or multi-use. They're multi-use, and not only do they have what people need to take their showers and cook and all that, but it also includes the requirements for fire protection. So you have to be able to cover both. You can't. There's not a separate fire protection system and then a separate just like a normal use water system. It all comes together. And if you look, this is a pretty good picture. I got some pictures that they gave it that pretty good, talking about what happens with the water system. And there's some videos I'll try to put on as well. Basically, you look at whatever the water supply is. And then, okay, this is a nice spring coming off a mountain, but it really doesn't matter. You have that. It could be a lake. It could be a river. It doesn't really matter. Wherever you're getting your water from. It could be wells. A lot of places, if they don't have a big water source like we do in the valley, they pull it out of wells. So they get it from the water system or from their water source, and it gets purified in a number of ways, and then it gets pumped out. Every system has to have some sort of purification system. And now how it's fed one of three ways. The first way is a gravity system. And if you look at this situation, okay, you have a dam. It's coming off the dam. You have your head pressure coming off that. It's flowing downhill, goes through purification, and then goes to the city. That's not used very often. You really have to be in a situation where it's going to flow downhill. Then you have a direct pumping station, and that is where you pump at pressure to from the river or whatever it's going to be. Your pumps within your system provides the pressure for the entire city or the municipality. And then you get, which is probably the most common system, and that would be a combination system. So you have your pumping station, you're pulling out of a river or a lake or whatever it is, or off a well. You can have it off of a well as well. And then it goes and gravity is being fed basically through the water tower. And we'll get into how the water tower works a little bit more. But it's going through there, and that's what's providing pressure for the city. Now, piping is really the key to all of it. And water pipes, not all are created equally. If you look at this drawing, what you see is there's the primary feeders, and those are big, big pipes. Here they're talking 16-inch pipes. They could be bigger than that. I've seen 48-inch pipes, 4-foot pipes as feeder pipes for large cities or large, especially large industrial areas. So some of these can be very, very, very large. And then in between there, you have your secondary feeders, which gets down to about 12 inches. Then you have your distributor pipes, which gets down to 8 inches. And then from there, you're actually going to have your service lines that either go into your house or go into your municipal area. Really, it comes down to what your water usage is. So, for example, we look at this right here. If we have a big factory right here with a huge water consumption, chemical plant or something that needs a massive amount of fire protection, we may tap either right off of this 12-inch line or right off of this primary feeder. We're probably not going to pull off this 8-inch because we're going to have to tap so many times it's not going to be worth it. So where you tap off of completely is based off of what your usage is expected to be. And then you also see on here you have the different fire hydrants. And the fire hydrants are typically off of your 8-inch line. Not always, but typically. That just seems to be the way that it's designed. And again, I'm not a hydraulic engineer. I can't tell the exact reason, but I'm sure they do. I'm sure they have a good reason. And then we get into storage tanks. And in storage tanks, they're water towers for the most part. And they do a very, very important thing, and that's provide pressure to the system. So basically, this isn't designed to hold water. You don't fill it up and then let it out. It's not like a toilet in that way. All it's there for is you fill it up, and that provides the pressure to the system. That way you're not reliant on pipes. And this is why it's part of the combination system. This is the gravity aspect of it. It provides that head pressure. I don't remember the exact physics principle, but your water, it's all going to reach the same level, and it's going to give that pressure down onto the pipe, and that's what's going to help push it up everywhere else, and that's what gives you the water pressure throughout your entire system. Now, an interesting point with all of your water towers, if you look at, I live in Oshkosh, so I'm going to use the city of Oshkosh as an example. I think we have 3 or 4, maybe 5 water towers around the city. The water in all of those are exactly the same height. Now, one may look way, way, way taller than the others. One may look really, really short. But from a sea level approach, all the water is at the exact same point because it's going to seek a level. So unless it's somebody isolates valves going to or from it, it's all going to stay at the exact same level. So that way you keep consistent pressure throughout the city. If you have poor water pressure and you know that your pipes aren't clogged and the pipes are all good, chances are you don't have enough water towers. That's what the cause of that is. You start looking at isolation valves. It's really important. You got several different places, and what they do is they help isolate areas. So if you have an area that you're going to be working on, it gives you an opportunity to cut off water to that area. A couple of rules with that. They're really intended for minimum disruption. That way, if they have to close a valve, as few people are going to be as affected as possible. But that being said, they don't want to have them every 20 feet. There is a set. This is how far you could cut them off, and we have a slide coming up that goes through those lengths. Really, and they have to be tested once a year. A lot of people don't realize that, but even if it's just being cycled, the city's going to come through and they're going to cycle the valve. That way, they don't seed into the point where you can't use. They're not going to be they're not going to be usable when you need to. Located on an easement, so it's public property. They can get to it below ground, so nobody's going to hit it. They're usually marked, and I think usually is the key point there. If not, they have their maps. Again, depends on the municipality. They just came through and marked ours in Oshkosh this year. Over the summer, they were there with their blue paint, and they marked the curb where they were at, and went through and double-checked where all the valves were. I mean, most of them were grown over. The service lines into the house, most of them got grown over by grass. So, and then usually indicating type for private systems, it's going to say whether they're open or shut, and it's going to be, for the people that need to know, they need to know. So when you look at the typical types, it's control valves. If you're a sprinkler system, we're going to talk about sprinklers in a few weeks. That one would be a PIV, position indicating valve. It shows whether it's open or closed. And then a water flow meter, backfill, or backflow preventer are also going to be installed. And this is going to be, okay, the control valves between the public and the private system. So, for example, you're in a factory, you're bringing water in from the city. You're also going to have your own little system there as well, all of your piping. So it's going to be, with that, it's going to be a water flow meter, so they know how much to charge you for your water. There's also going to be a backflow preventer. This, think of like a check valve. That way, any contamination you have within your system isn't going to back out and get into the private water system or the public water system as well. You don't want to be contaminating everybody else's drinking water because you have an issue within your plant. That's what the backflow preventer is for. Fire hydrant, where they're at, connected at specific intervals, usually 300 feet apart in high-value districts. They're there for a reason. Typically they want them every block or so. Intermediate hydrants would just be something in between. Some of the things it's going to depend on, some of it's going to be building construction. If you have a bunch of wood construction that are going to be closer together, if it's all masonry construction, masonry doesn't burn, you're probably going to have them a little further apart. Occupancy, if you have a hospital, you're going to have a whole lot of extinguisher or hydrants. If it's high value or high hazard industry, you're probably going to have a lot if they're close together. Size of the water mains. If you're running off an 8-inch main, you're probably going to have them closer together. If it's a bigger one, you may have them a little further apart because they want to see how much water they can get out of that. And there's all kinds of stuff when you look at. You have a dead end hydrant, and that's right off the end of the pipe. You may get less pressure from there, especially if you're pulling from other hydrants along the way. Then you have a circulating hydrant. You see you have connections from both sides. You may get more with this one because, for example, so like let's say you have another hydrant on this side, and you have a hydrant on this side. Change my color, and I'm going to apologize for the poor drawing. This is connected with another pipe going this way, another pipe going this way. So if you're pulling from here, you're pulling from here, then by being circulating, you're still getting water from these other feeders or connectors on the opposite side. Where if you look at this one, if there's a hydrant here that you're pulling from here, you're probably not going to get too much more water out of this one. And that's why when you're connecting or putting your hydrants in, you have to think about that kind of stuff. You really don't want a dead end hydrant because it just isn't. It's nowhere near as effective. Fire hydrants, they do fail. Not very often, but they can. You have your damaged fire hydrant valves and connections. It's a mechanical device. It can break down. It doesn't happen very often. Broken water mains could be a big one because if the water mains feeding the fire hydrant aren't working, then they're not going to work either. Greater demand than the system can provide. Usually you hear about that with big fires. With you have multiple fire engines pulling off of a small system. You just get to the point there's just no more water there. Dead end water mains we talked about. Closed isolation valves. So you have a valve somewhere along the way that's closed that's not supposed to be. Restricted mains caused by sediment or mineral deposits. I mean, if water is not flowing, things are going to start building up. And that can cause issues when you do start flowing. And then pipes or hydrants that are frozen. Typically, these are put low enough or far enough down into the ground to protect from freezing, but the hydrants can still freeze. And we're going to talk about the different types of hydrants and how they protect against that. But hydrants freeze. Pipes can freeze as well. I remember 3 years ago. We had some problems throughout this area. It was so cold for so long that the freeze actually got down to the pipe level. And we did have some pipe freeze-ups in the ground. I know I had a plant I was working at, we had a sanitary sewer that just kept freezing up because it was just so cold. It wasn't that far underground. But we did have issues. That was the first time we'd ever added something like that before. So, things that we're going to look at, common things that we may encounter. Construction material, they're all going to be cast iron or foundry iron of some sort. It's just what's used, especially around here. You're going to have one big opening. That's for a big hose, and you're going to have two small ones for small hoses. You want to make sure that they're all set. And really, we got two different types of hoses. This dry barrel, that's going to be what we see here. So this is the part that you'll actually see. Oh, sorry about that. Let me draw again. So this is the part you'll actually see that looks like a fire hydrant. So we see that right there, and then you have a long section of pipe right there. And that pipe could be, in this case it looks like, well, this is the hydrant, then you may actually have pipe from here as well. And basically what happens is this operating stem, you turn this open, and then all of a sudden water floods here, and you can get it. You get water out the side. In warmer climates, if you go down to Florida, you get the hydrants look very, very different, and that's because the entire barrel is charged with water the whole time, and then you just open it here, and that's how you get the water out. That's why if you look at the movies and they hit the fire hydrant and water goes spraying all over the place, that is that has to be a wet barrel. If you do that to a dry barrel, you're not going to get anything to spray because there's no water there. As opposed to this one where you hit that and you have a chance of water spraying all over the place. The colors on a fire hydrant does matter. If you look, this is NFPA, so of course nobody actually follows that, but they do have specific colors. The barrel color, the fire hydrant itself, they say should always be yellow, that way you can see it. And then the caps and the nozzle are going to be painted different colors. And that's going to correspond with how much water you can get out. Now that means absolutely nothing to most of us, but if you're driving a fire engine and you know you're going to need a lot of water, you may drive past one that has a red cap in order to get to that one with the light blue cap. So light blue, that's going to give you the most water. That's going to give you 1,500 gallons per minute or more. You get into green, that's going to give you somewhere between 1,000 and 1,500 gallons per minute. Orange is going to give you 500 to 900, and then a red cap is going to give you 500 gallons or less. So that's what the colors in the fire hydrant means. Then you start running into some problems you can run into, especially when you're doing your inspections. So you look at this hydrant, you have a giant tree that's grown up right next to the hydrant. It's probably not going to work very well. You're definitely not going to be able to connect to it. Now that could be a simple repair, it could just be cutting down the tree, or it could be a complex repair. The key is, and this includes for us in industry, we want to identify that early in the game. That way we don't have a fire in our facility and then all of a sudden finding out, oh my goodness, this hydrant's not going to work. So far we talked all about hydrants and stuff, but there are a lot of other options as well, especially if you get into the rural areas. You get outside the cities, they just don't have fire hydrants. They're not set up that way, so they have to do other things. And they have to use things like private water systems. They have to use lakes, ponds, rivers, the ocean out west or out east, swimming pools, large stock tanks, rainwater collection. There's a lot of options out there that they have an opportunity to pull water from. You have to make sure it can provide you a significant or sufficient quantity. You don't want to drain that dry and have that be your source of water. You don't want to contaminate with any health hazard that all of a sudden you're going to be spraying that out and it can contaminate people. And then you have to think about depth. I mean, this picture doesn't mean anything to us, but You have to think it has to be at least 4 foot deep in order for the strainers on the fire trucks to work right. Again, there's people that are going to worry about this, not us, but it's good information to have. The big thing is you need to have it planned. And from the industrial standpoint, you have to think, if we have a fire in our facility, what are we going to do? How are we going to, how is the fire department going to get water to us? And do we need to work with them on that? And with that, how can we help them as well? Point Beach Nuclear Plant, they have their own system, and they put a hydrant outside their protected area for the fire department to hook up on to, not only for fighting fires at the power plant, but also if they needed to get access there, because it's a lot faster to hook up to a hydrant than it is to try to draft off of a river. So, what happens a lot of times is they'll set up these tanks. They look like kind of giant swimming pools, and they'll fill that up, and then they'll pull water out of there. And then you just get the line of trucks that fill up. I mean, you see this truck dumped in, and you see all these other trucks. They're all lined up just to pour water into there, and that's how they fight the fire. It works. It's rather inefficient to start off with. So it's one of those things you have to consider if you have a rural factory. What are you going to do for a fire protection? And then this is just a close up with the picture of the drop tank and how they pull water out of it. So, like I said, the shorter video. We don't have as much information. I'll see if I can find some more information to give you. So that's really all it is for this one. If you have any questions, please let me know.